For this video, I am going to derive the quadratic equation. Why? Because when you derive something and you know the logic to reproduce it, you internalize it. That is to say, you are more likely to remember it in the future. So let's start with the basic, the quadratic equation. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. It's something a lot of high school graduates have memorized for all eternity or have already completely forgot it. It's kind of a long, ugly formula that you have to use a lot. But I find a lot of students don't know where it comes from. So let's try to analyze it and see if we can break the formula down. Let's start by looking at the input, a function in the general quadratic form. We want to find values for x, which lead this equation to be equal to 0. If a was equal to 0, we would just have bx plus c equals 0. Which would be really easy. We would just subtract c on both sides and divide by b. And get x is equal to c over b. It was pretty easy to isolate x. The issue here is we have two x variables that we need to account for. Usually when this happens, we try to factor out an x. But we still have no way to isolate x. But we do know one thing, that when we do find the values of x, we can express them in a grouping form, like such. X plus alpha times x plus beta. So all we're looking for is two values, alpha and beta. Well, wouldn't it be nice if alpha and beta were the same value? If that was the case, then we would have this or this, where x is isolated. Even if we had the variable c over here, it would still be quite easy to solve. Subtract c on both sides, find the square root. Subtract alpha. And we will get this value. This is even starting to look similar to the quadratic equation. So again, we have ax squared plus bx plus c equals 0. And we want it to fit this general form. Can we achieve this? If you watched my completing the square video, that method should be screaming out to you. If not, I recommend you watch that video as well to further grow your mathematical intuition. Either way, using the logic behind completing the square is the key to this problem. So again, we have ax squared plus bx plus c, and we want it to fit the form x plus alpha squared plus c. If we factor this out, we know that this form will produce square this, double the product, plus this squared. Now we can't do a straight comparison, because if you notice, the x squared here has a 1, but this x squared has an a. And a will not always equal 1. However, we can divide this equation by a to fit the form. So let's divide by a. This yields x squared plus b over a x c over a equals 0. Now if we compare them, that works. And then we have b over a is equal to 2 alpha. Therefore, alpha is equal to b over 2a. So let's redo this formula over here. Now we can replace alpha with b over 2a. No, I did not match the third term because I am not trying to use a third term for the function. I am only concerned with the first two, the ones with x, when completing the square. So now let's replace alpha in the function below. So from a direct substitution, we get this. As you see here, the 2's cancel out, so clean it up. So it's looking pretty similar to what we have here. X squared, b over ax. The only difference is this constant. So if we add this constant to both sides, we haven't changed the equation. Or another way you could think about it is if we add the constant here and subtract the constant, it would be the same as adding 0. So let's do that. So if we add b over 2a squared and we subtract b over 2a squared, we essentially added nothing. We haven't changed the function. Now this matches 1 to 1. Therefore, we could replace this whole thing with this short version instead. Let's do that. Now let's move all of these constants to this side of the equation. Now if you remember from earlier, this is in the same form as x plus alpha squared equaling some constant. So we're doing well. We can now solve it relatively easy. Which looks close and very similar. So let's try to simplify the radicand and see if we get to match the quadratic equation we all know and love. So if we distribute the square, we get b squared over 4a squared. Again, looking very similar. So let's try to match the denominator. So to do that, let's multiply what makes these two things different. So this one already has an a, so we need one more a and a 4. So that means you have to multiply this by 4a. So that way, in essence, we're only multiplying by 1. Multiplying anything by 1 doesn't change anything. Now that we have the same denominator, we can combine the numerators. So now the equation simplifies a little bit. Still go further. We can take the radical and separate it by the numerator and the denominator. Looking very similar, isn't it? Here we could pull out a square, and the square root and the square will cancel each other out, meaning that this denominator really only becomes 2a. Now that these guys both have the same denominator, we can combine the numerators and keep the denominator again. And then boom, we got what we wanted. We were able to go from the general quadratic formula to the quadratic equation to solve for the roots of the zeros. Please subscribe, share with your friends, people take Algebra 1, Algebra 2, high school, anyone that wants to relearn math, and comment on whether you like this video or not, how it can improve, and what do you want for the next video. Thank you.